Okay, hello everyone, and welcome to the Gulf Coastal Plains and Ozarks Landscape Conservation Cooperative's webinar presenting the results of a project entitled Black Bear Habitat Assessment and Associated Landscape Conservation Endpoints. I'm Greg Elliott, providing communication support for the GCPO LCC, and Toby Gray, our GIS analyst, will be co-host today. This webinar will be recorded and posted on our YouTube channel. It is also pre-approved by the Society of American Foresters for 1 continuing forestry education credit. At the end of the webinar, we will post a certificate of completion and directions on how to submit for credit approval from SAF. Today, you remain muted during the presentation, and we encourage you to submit questions at any time via the question box. We will also be asking you a few questions during the presentation. At the end, we'll have Q&A and try to unmute people for that. Here's a little background on us. The GCPO LCC is part of a national network of 22 LCCs that cover the entire U.S. LCCs are applied conservation science partnerships that provide scientific and technical support for conservation and natural resource management at very large or landscape scales. The GCPO focuses on a 180 million acre geography that covers all of Arkansas and Mississippi and portions of 10 other states centered around the lower Mississippi River. Today I have the honor of introducing Dr. Jennifer Murrow. Dr. Murrow is a spatial wildlife ecologist at the University of Maryland. She received a Bachelor of Science from Clemson University in Wildlife Biology, and at UT Knoxville, she received a Master in Science in Wildlife Biology, studying black bear ecology in the Southern Appalachians, and then she received her PhD. Her research focuses on wildlife habitat use and modeling with a specialty in GIS applications, and now I give you Jennifer.
Okay, hi everyone. Thank you for joining us today. It's been my pleasure to work on this project. I'm going to walk through the presentation. It will probably be about 30 or 40 minutes and talk to you about the work that we're just wrapping up now. It was really an exciting experience to get to work with the GCPO. We're going to talk today about bears and forests and bears and foresters. And before we get full-blown into the presentation, I want to do our first poll, which is looking at who's joining us today. So Toby, would you mind launching that question, please? And let's just get a feel for the members of our audience.
Okay, the poll is up, and give you about 40 seconds to select the description that best describes how you spend your time at work. Looks like about 80% of y'all have voted. I'll just give you a few more seconds before I close this out. And it looks like we've got a pretty good mix, but unfortunately there are no private landowners.
That's okay. That will at least help me kind of in terms of what we emphasize and not emphasize. Okay, thank you very much. Okay, just so that we're clear for the state and land managers that we do have and foresters on board, I am not a forester. And so that will become pretty clear. So, but I did become really interested when the GCPO was looking for kind of specific management goals for a lot of the species that they're interested in terms of forest. I found that question pretty intriguing. And what you're looking at right now is a 2011 national land cover that was anything that could be potentially considered forest. So it does include woody wetland, which is a little hard to see on here, but we're talking about having greater than 4 foot in terms of tree cover for most of that. And then if you overlay the most recent IUCN bear range, black bear range for the lower 48, you see pretty quickly there's a really high correlation of where bears are as it relates to forest. And this is something we've known for a really long time. This is really no big surprise. But as we see forest industry change, it becomes pretty important. One of the things that kind of sparked my interest when I saw this RFP is the fact that a lot of our hardwood and mixed hardwood forests, they're being used, and it's not just the residuals. They're being used to create wood pellets that we're shipping to Europe. And we know as the U.S. kind of changes our track, a lot of those pellets are going to be staying in the U.S. And so our forests are a really important renewable resource that we need to be able to maintain. If we can concurrently manage them more efficiently for bears, then we're hitting kind of that multi-use need. And so that was my idea with this project, was starting to try and use more recent technology to get at what is this forest really inside of this bear range. So today I'm going to present this project, and it came in 3 kind of big steps. The first was identifying habitat, which I've done for a long time in a lot of different ways, but doing it throughout a huge chunk of the GCPO, and then identifying forests within that habitat, what we're going to say is quote-unquote good habitat for bears. And then look at management of those forests. What is the forest specifically composed of, and how might we balance that such that a forester has a good livelihood, a healthy forest, but bears are also benefiting? How can we maximize that? So those are the general overall goals of the project. More specifically, we had to create a bunch of layers in terms of habitat model, and then build many models, and then identify the best model in some way. And then we chose to shift into using LiDAR technology to start to look at some of the basic forest characteristics kind of much more specifically, and then we moved to FIA data to get at a lot of the forest traits that are micro characteristics that it would be illogical for us to try and go and do across all of Louisiana and Arkansas given time constraints and logistics. Okay, so the basis of this model are bear locations, and these are all of them. There's more than 50,000 bear locations. They span from coastal Louisiana through Arkansas. That being said, let me also say that the Louisiana data is very different than the Arkansas data. Louisiana data, because the bear who's just come off the threatened and endangered species list, Maria Davidson, you can see there, they have had out GPS collars, and I've had access to all of that data. And so we ended up with 2 data sets that are kind of disparate. We have an Arkansas data set that's pretty old and not very many locations. And we have a Louisiana data set that spans from Dr. Pace's time at LSU all the way through, actually, I have locations coming in from 13 and 14 as well. So that's a problem, and how do we address that? And so looking at these years, we immediately realized I'm not really sure how we're going to handle this in terms of land cover. Well, luckily, land use change is a really hot topic, and some other researchers, some actually here in the geography department of Maryland, the University of Maryland, have done massive land use change looking from 1992 up to 2014. And so what we were able to do was to go in and look. We had created 75% kernel home ranges for these bears, and we went into their home ranges and actually looked at the change of the land cover type in the NLCD data, which was going to be the basis of our analysis. We looked at how it changed between those sets of years. And lo and behold, we had less than 1% change, and most of that was in ag. As ag went fallow or matured and then was cut back again, we saw those changes. And so we felt pretty confident ignoring this for now and moving forward. The other complement to that is we're not actually using the telemetry location as the sampling point, so we avoid a lot of bias in that way by using the home range. Okay. So the extent of the model, computationally, this is extremely intensive. So this is the 30-meter square resolution. And at this point, without having a dedicated server, it was just infeasible to do the entire GCPO. We hope to actually eventually extend that throughout the entire GCPO. But for now, we just did Arkansas and Louisiana. And we have several different extents. So we obviously created these home ranges, a kind of conservative home range because it's a 75% home range. And then we had evaluation areas. So that's groups of bears. So coastal Louisiana, the Atchafalaya Basin, Tensas, southern Arkansas, and then the Ouachita and Ozark Mountains. And then, of course, we have the entire state that we ended up building the model for. We had a lot of source data. I've built a lot of bear models over the years. And so in particular for Louisiana, so I have data that I feel really good about and know where it's come from. Louisiana is a little unique in that it has a water component that makes it a little bit difficult, especially in the Atchafalaya Basin. So Robert Greco with Fish and Wildlife Service has some very kind of specific GIS data that he allowed us to use, along with having to deal with some water gauge issues of what's really woody wetland that the bear could use versus typically underwater. And then we went through pretty much throwing the kitchen sink at what could be important for bears. So this was from a huge literature search and past experience. And we did a lot of landscape variables. That's these. So trying to look at patterns in the landscape that aren't just immediately obvious to the human eye. We also looked at a lot of different road variables. In this type of modeling, distance to road variables are often, they create patterns, false patterns in the model itself, and so we ended up looking primarily at the density measurements of roads for this model. And then, of course, land cover is important. Mast forest is any forest that makes a significant hard mast species. Natural is anything that is actually green, basically. An ag, distance to bear ag, because from a previous step selection modeling process, we figured out that there's a lot going on with ag, wherever there is ag with black bears. And then you'll see the starred weighted bear cover. The next slide is going to talk about that. It's a pretty unique thing that we tried, and it ended up working well for us. Public land, which may or may not be important. Usually people think it is. And then obviously water is important. So those are all of our variables that we included, about 27 of them. So this is Mike Hooker, and I put this slide up here because that starred variable you saw is actually what's considered an expert model. Basically, I took the cropscape data, which is agricultural data based off of the most recent NLCD, but down to very fine scale of crops, even if it's a double crop during different times of the year for the same pixel. And I condensed those crops and sent them out to experts, whether it be state or federal managers. Mike Hooker filled out one of these for me, many different researchers, many different bear biologists, and asked them, what are bears using? But I wanted to know more than just that. I wanted to know, are they walking through it? Are they damaging it? Are you having people call because of it? Do you know they're eating it? Are you seeing it in their scat? Is this something that is always considered kind of very high quality? And based on a summarizing of those results, we weighted every possible land cover from urban to a deciduous forest with the values of 0 to 5. So urban received no weight, whereas woody wetland and deciduous received a value of 5. Corn and soybeans, which especially corn is a huge food source for bears but can be contentious for humans, got a 4, and so on. And so inside the report, the kind of rationale for this is laid out. But this is actually considered an expert model, and you don't typically include a model within a model. So this was a little kind of something different in terms of how are we going to classify the land for bears across such very different habitats from coastal Louisiana through the Ozarks of Arkansas. And this was the way I thought we might try and approach it. So then we had to do a lot of model variable reduction. 27 is just way too many models, way too many variables. We didn't want to be continuously redundant with our variables that are basically saying the same thing. So we went through a long iterative process, and we looked at things like the mean of the variable within the home range versus the evaluation area versus the state. And for example, if the means were all basically the same with the same standard deviation, that variable was telling us nothing. And so we just chunked it. The other option would be if you had very highly correlated variables, which was probably the primary way we reduced variables. We would only choose one of those variables that had, in our mind and based on a literature search, the most biological relevance. It got us down to actually only 4 variables. We ran I don't know, hundreds of models, but we ended up always coming back to these same 4. Water density, the weighted road density, which is just a 1, 2, 3 based on primary, secondary, or tertiary, distance to urban area, and weighted land cover. So that's that expert model. And these are those 4 variables just to kind of give you an idea of what they look like. So we have water. That percent bare is that expert model, distance to urban area, and roads. In terms of the modeling technique, I had actually intended to do maximum entropy. This was not the best data set for maximum entropy, and so I went back to my old standby, the very elegant Mahalanobis distance statistic. I'm not going to spend a lot of time talking about this statistic. If you're really interested in it, I give lots of details in the report of how we did this. But suffice it to say that it's a presence-only, a method that uses presence-only data, and it's a measure of dissimilarity. And that will be important because I'm going to talk in just a few moments about the relationship between those variables and this statistic it creates. And you want to remember that smaller values mean better bear habitat. So we're trying to get closest to 0. Okay, so without bogging down with a bunch of statistics, this was the PC analysis, or the principal component analysis for those 4 variables. And you can just, look at the inside of the red box is the primary thing I want you to walk away from, because this first eigenvector, this first variable load, so all 4 load on this first vector, carries most of the explanation for how the model did. And so what you see here is, let's look at water first, 0.73. It's a pretty high number. You usually look at what's weighted at 0.5 or 0.6 or higher. So we would theoretically see distance to urban area and know that it doesn't do very much. Water is very high, 0.73. It's also positive, which means it has a positive increasing direct relationship with the d-square score. And if you remember, we're trying to get to 0. So as water increases, the d-squared increases. So we move away from good bear habitat. Versus the bear variable, which is also weighted pretty high in terms of it being a 0.59, but it has a negative relationship. So we have an inverse relationship. So as this expert model increases, so those values of the 0 to 5, as that increases, the Mahalanobis distance statistic decreases. So it gets more close to ideal or good bear habitat. And so we saw this result and we were pretty excited. We're like, oh wow, this is what we were hopeful for, but you just never know when you start modeling what's going to happen. The other thing about Mahalanobis is that it's just a number. It's just a statistic. For it to mean anything, you have to decide what it means, like where is good and where is bad. And there's several methods that have come out to do this. The primary driver of this work is Boyce, and he has come up with several different ways to kind of classify Mahalanobis. And the most elegant way is the cumulative frequency distribution. And what you'll see, this top orange line, that's the cumulative frequency distribution from 0 to 100% of your bears, so the bear home range values of the distance statistic. And then you plot that against random home ranges, which I had to create inside of GIS. And you plot them against each other, and you're looking for the place that they are the most different. And that is where you're going to tend to balance the sensitivity and specificity of the model. In this case, the highest point of difference was at the number 12. So 0 to 12 is kind of the ultimate quote-unquote good bear habitat. But we had a second peak in threshold difference. It was just below that of the 12, and that was 23. And so usually we don't include a second peak, but in this case they were so similar, I thought it was worth including. And so when we look at the model in just a moment, you'll see that the 0 to 12 is really good bear habitat, and 12 to 23 is still fairly good bear habitat. Okay, so here's your model. Brown, dark brown is 0 to 12, and then this kind of light tan is 12 to 23, and then everything else really could be kind of lumped together. But as I said, managers have a lot of leeway with this in terms of how conservative or liberal they want to be in what they define as good bear habitat. I was mentioning to Greg earlier, it's really interesting and worth potentially checking out if this is something that you find intriguing. The GCPO has been a part of coming up with kind of this blueprint of priority areas, and they've done this as a combination of 6 other, I believe, LCCs, and it's eventually going to be posted on the Southeastern LCC website. And so they have almost well, more than just the Southeast, but the Southeastern U.S. in places that are priority. And if you overlaid this map with this blueprint of where they're saying the priority areas for conservation are, it's pretty intriguing how similar they are. And that speaks to the black bear's ability to operate as kind of this umbrella species. Okay, so on from the model, this is my diorama. And in general, models are models. You know, there is no perfect model. And to have any kind of confidence in the model, you have to do some very rigorous testing. And we did a tremendous amount of testing of this model. That's usually what actually takes the longest. We did leave one out bootstrapping. We did random subsampling bootstrapping. We did testing it with independent data, that GPS collars that weren't included in the model. And we also tested it with data from hair snares where bears had been had left hair as an individual, and looked to see, we knew they were standing there, so what's the D-square score for this particular pixel? At the 12, so the model overall did extremely well. At the 12 threshold, this model was predicting bear habitat at 75% or greater of the time. At the 23 value threshold, we were at 95% of the time. Throughout all of that, in general, the model was continuously doing very, very well at being able to say whether or not this was going to be good bear habitat. So we were really pleased with that, and we're willing to move forward after seeing those test results. Okay, so let's move into kind of the second part of the project. So we have a habitat model we feel pretty good about. Now we're moving into the forest itself. So the first thing is the LiDAR data, which I had not had a tremendous amount of experience with before. I knew that we were making leaps and bounds in terms of what we were going to be able to do with LiDAR for habitat use. But we have seen, you know, initially LiDAR just kind of being elevation data. This is kind of a laser that beams down to the ground and records like when it actually returns back to the laser itself. And then we saw a step up in looking at like profiles of trees, and then the most recent, we're seeing leaf on versus leaf off scans to look at more 3D structure of canopy cover, can be used for finer scale species and habitat quality, also tree health, and many other things. We used the LiDAR with the intent of looking at these 2 variables, and I'll explain them in just a moment. But you'll see that across the top row is canopy height, and across the bottom is percent canopy cover. We also intended to do some biomass calculations, which, as we expected when the project started, are not as straightforward as one would hope. And so we're still kind of working on that and seeing what we can get out of it. When we started going out and seeking LiDAR data, Arkansas has very limited LiDAR that is available. And we didn't want to do LiDAR. We didn't want to quantify the LiDAR forest data only in areas where this model said it was very good bear habitat. We wanted to do it in areas where we knew there were actually bears. So we wanted to have high quality and occupied area. And so it really limited us in Arkansas. Luckily, the state of Arkansas had just finished a LiDAR project, this particular county, and they were willing to share it with us. But we didn't have home range data where it was. And so we knew where the high quality bear habitat was, and they also happened to have wildlife management areas that were currently being hunted for bears. And so we could feel very confident that they were occupied by bears. And so that's on the left-hand side in Arkansas. On the right, the state of Louisiana, through the Atlas program, has full point cloud LiDAR data available for every section of Louisiana. So we didn't have that issue. We could go in, clip out high quality habitat, clip out sections of home range, and then quantify the forest and what was going on. The canopy height, you can see really tall trees come out as red and really open areas come out as green. Kind of a little bit of the inverse in terms of percent canopy cover. So we have really high canopy cover in blue and really open canopy cover again in kind of a light green. And so we were able to start to quantify a couple different things. Overall height distribution, canopy cover distribution, and one thing we're doing right now is the spatial distribution of open versus closed. And I'll talk about a little of that later on. So we came up with these graphs that kind of represent what the distribution looks like across our study areas. And you'll notice southern Arkansas, which is our 6th area, isn't on here, and that's because we didn't have the LiDAR data there. So from working from the top to the bottom, the coast of Louisiana, the Atchafalaya, Tensas, Ouachita, and Ozarks. Interestingly, we had the most canopy cover in general in the coast of Louisiana. And I don't know why. That was just a little bit surprising to me. Atchafalaya was kind of this mixed bag, which we expected, where you have a little bit more open, but you also have sections of it that are much more closed and, in fact, have much older, taller trees. Tensas, Ouachita, and Ozarks kind of had very similar patterns with different actual ranges in general. And then in canopy height, you know, the patterns kind of hold there, and you can see. And so it started to help us kind of understand what's going on within this very high quality occupied forest as it stands right now. Now, keep in mind, this is not to say that this is an ideal bear forest. What this is where the bears are right now. So this is important because a lot of places throughout Bear Range, you know, they're already in areas that are less ideal. And so when we get to the management conclusions at the end, you'll see how that might tie in. Okay, so we started to describe stuff via LiDAR throughout this bear forest, and then we wanted to get a finer scale, and to that we looked to FIA data, which many of you are probably quite familiar with. I had not really delved into a lot of FIA data. Wow. Well, first of all, I signed my life away to Sam in Knoxville, and then he helped me actually access a lot of this data. And this is a massive program with incredible resource for a wildlife person who's doing habitat modeling. So they're going out in forests across the U.S., doing sampling all the way from fungus up to the tallest tree. So like I said, I sent Sam Lambert in Knoxville, I sent him a shapefile of all the areas that were that 0 to 12, so the really good bear habitat. And he pulled out the FIA plots that were within that area and then sent me back a file of all the information from them. And I've given you a picture of one. And there was initial concern because, of course, there's like a fuzzy tolerance of where that's actually located, but we had such a buffer around those areas of 0 to 12, we didn't think that it was actually an issue when we went to look at where these plots were. So here's an example in the Ozarks, and this is kind of a more close-up of what it looked like. So we have FIA plots within a wildlife management area within high-quality bear habitat. And so then it's literally hundreds upon hundreds of Excel sheets of data. So I'm going to give you some of the general conclusions, and I want to reiterate that this is a lot of tables, and so I didn't want to burden you with a tremendous amount of detail, but there is the report, which will be sent to you actually in a link because you participated in this webinar. And also, while I'm mentioning that report, if you want to dig into more detail, the D-squared model for Louisiana and Arkansas at the 30 by 30 meter resolution it's up on the data basin for the LCC and will be available for you for download. So it's available to the public now. So in general, the forest types that we saw were not really surprising. This was what we kind of expected to see, and in fact we did. Tensas, Atchafalaya, and the coast of Louisiana were primarily oak gum cypress forests. Tensas has a star because it was the one of those three that actually split out almost 50-50. Tensas ended up having elm, ash, cottonwood as well. Southern Arkansas was kind of a mix of oak gum cypress and loblolly shortleaf. So you can see as we're moving up in latitude that we start to have the evergreens kind of come in more. And then the Ozarks and Ouachita split out pretty evenly. Ozarks, oak hickory, Ouachita were loblolly shortleaf. In terms of tree characteristics, I'm gonna give you some generalities here, but this was across a lot of data. Most of this timber inside of these occupied high-quality bare forests would be considered merchantable. So most of them had the 7-foot bowl and tree to be able to actually use in the hardwood. And most of them were at least at the 50% or more point of quality in terms of forest. And those were the things we were concentrating on, were the species that were there, the DBH, the length of logs, and the quality. So you'll hear me talk about that. DBH was lower than we would have expected. We were seeing DBHs of ranging in general from averages. So this is across evergreen and hardwood, but 7 to 15. It probably averaged around 11. But even the hardwoods, were averaging around 15, which was a little surprising. Age-wise, age estimates that these forests were averaging around 40 years of age. And in terms of biological potential or bear potential, as a bear biologist, I would have considered these forests healthy in terms of being able to produce for bears hard mass, but not necessarily in peak condition for bears. And we'll talk about that in just a second. Let's go step by step at the site, and I've got a few comments about it. And remember, FIA is split into different things. So we saw forest type, which is different than species group, and so I'm giving you data in a couple different varieties. The Ozarks, you could see the primary species in the Ozark is actually hickory. But when you start to look at biomass in general, we see that there's a lot of the white oak and select red oak. And we also see that they are fairly well balanced in terms of having, of those two big categories, half white and half red. And we'll come back to that in a moment. So looks pretty good for bears. Ouachita, as we would not be surprised, primarily loblolly shortleaf, although there are other trees in there, they just are not nearly dominating, or the diversity that you see in the Ozarks. It's very much because of soils and geology dominated by this kind of loblolly shortleaf pine ecosystem. There are some oaks, though, and the oaks that are there are split fairly well between the reds and whites. Southern Arkansas, we had only one FIA plot, so we'll have to take this kind of with a grain. Now, knowing that they do multiple plots within one FIA site, there's enough information to come up with means and standard deviations, but still, we don't have a lot of data here. So this one primary site was primarily loblolly shortleaf, and then had a breakdown of other reds, but didn't really have very many white oaks. And in fact, when you dig deeper into it, you see there's around 5% white oak. And so we see kind of a very quick drop-off for white oak. White oak are important for bears in particular, whether that's a swamp chestnut or a regular white oak. It's important because they're typically more consistent in terms of, and this is really a generality, but in terms of their acorn production. They also tend to produce a little bit more when you have a healthy, robust tree in terms of acorns. And so it's nice to see a good split between the species. Tensaw. So tensaw has a lot of sweet gum, and that's the dominant species, which is not really surprising. And then we're backed up with hackberry. And we know that bears certainly utilize hackberry. And then there's a huge red oak component, so this is the primary. Now, I didn't include any of the percentages on these graphs that are 5% or less, so there's a lot more below this, but I wasn't going to bog down the slides. So red oaks, and what's interesting about tensaw, and I think it's important for the forest industry, is you see a breakdown like this, and maybe a forester automatically knows it, but it's not necessarily something a bear biologist immediately thinks of, and that is that when you start looking at growing stock in terms of volume per tree or acre, even though you've got all the sweet gum and all the hackberry that are actually the primary component of the forest, when you're looking at stocks, then all of a sudden all of those species are really not the big issue. And we see this being reflected throughout the forest. So the red oaks here are our primary driver in terms of kind of forest industry species. but we see really none. When you look down the graph into the smaller distributions, there's really no white oaks of any variety, and that's important in terms of potential suggestions as we move forward. And then FIA lumps the Atchafalaya and the coast, so they have to be looked together. That's kind of how the FIA lumps their areas. Again, we see these eastern soft hardwoods coming up like the hackberry, and again we see sweet gum, but we jump to other red oaks being Nuttall and water oak primarily, and they are again the primary growing stock in terms of the forest industry, and again we're missing any kind of white oak component. And while white oaks might not be in general as common, it's surprising that they were really missing in these FIA plots pretty much across the board. Okay, so before I move forward, let me go ahead and get our next polling question. In fact, we can do one, and I'll start the recommendations, and then we'll do the second one. Toby, would you do the metric question, please?
Here it is. What forest metric would you expect to be most easily manipulated in commercial forestry to accommodate bear needs? Oh, I'm about to close it. If you've got a response in mind, you have about 83% voting, and it looks like most attendees believe that it's the type of cut. A significant number think the species of tree or the rotation time.
Okay. Okay, so very good. That's helpful information. So I'm going to give you what we've kind of walked away, the big ones. There's a lot of more specific kind of management recommendations based on site and tree that we could get into, but the big kind of take-homes were spatial and then also some adjustments to general management, and some of that can benefit actually the forester as well as the bear, potentially in the pocketbook region. So the first, which is, I've read other bear management plans, but I've not seen anybody kind of put a finger on why it should be the way it is. But the first is kind of the spatial breakdown of percent that is in a closed canopy versus open, and whether it's early successional or late successional. And from what we're seeing in terms of this occupied quality forest, if you were a forest manager interested in supporting bear populations, you would want to have at least 50% or more of your canopy and 50% canopy cover or greater. And that's not surprising. I thought that was, pretty logical, and we kind of saw this as kind of an average of where these bears were. So that's a minimum. You could have more. And then a minimum, this was surprising because remember, this is within the forest. So this is not like ag land or anything like that. So this is within the forest because we looked at the canopy height via LiDAR of things from the ground, but also things that were at least 4 feet in height or taller, so separating trees from early successional. And bears tend to set up and do well and have really high quality habitat where it's a minimum of 25% early successional. And I don't mean young forest, I mean truly early successional. And in fact, we're still in the process of finishing a lot of the analysis of the spatial component of how that is kind of stratified within these areas, like how is it distributed, but for the most part it seems to be quite clumped. And this actually ties very easily into a forest management plan. This is something that can be easily done as opposed to these kind of very complicated spatial cuts. So 25% that you're maintaining in some kind of early successional. And then if you were going to just do 50% of your closed canopy, you could only have a maximum of 25% of the property in young trees. And by young trees, I mean trees that are an inch or less in DBH. So you don't want to have a lot of that kind of early, mid-successional habitat. That's not really good for bears, and that makes sense. So this was kind of the first big recommendation based off what we were seeing of the landscape and how it's spatially laid out for bears in these forests. And then, interestingly, it might not be the easiest to deal with, but one of the things that we've noticed is that the areas of the highest quality bear forest are not necessarily, throughout Louisiana and Arkansas, are not necessarily what a bear biologist might say are the best for bears. Because as soon as you start digging into the forest ecology and you look at the DBHs and ages or rotational time that these trees kind of hit their peak of acorn production, you realize that the forests where these bears are still just shy of the mark. Now, granted, I don't know what the rotation time for these FIA plots are. We don't have that kind of information. We can look at past history, but we can't look at what's happening now. So they may intend to let them grow for another 10, 15 years before they come in and do any kind of manipulation, but I don't know that. So assuming that that's not the case, there's potential to slightly lengthen the rotation of the hardwood species. For pulp species, this is not as big of a deal, but for the hardwood species it is. To try and get to that 20 DBH especially for the red oaks, and closer to the 25 for the white oaks, to start to reach that peak acorn production more consistently. Now, we know a lot of the oak species, if you get to a certain point, then they kind of start to senesce or they don't produce as many acorns. So I'm not saying to go much beyond that. But even the age of the forest as it stands is still pretty young. You're going to get more money, at least in the literature searches that we're doing. Maybe some of the foresters online would say that this is not necessarily true, but when you take your lumber or timber to market at these larger DBHs in 50 to 60 year age range, you're going to make more money. Now, say this is actually the plan for what's going on in Louisiana and Arkansas. What this is saying is we're potentially going to see an increase in the quality of habitat over the next 10 or 15 years, actually. So that could be a really good thing, and nothing needs to be done. But if there are forest management plans in the works and they're ready to go in and start doing, selection cuts or small clear cuts, if they can hold off or maintain areas that they do hold off in, this would be really beneficial to bears and potentially wouldn't hurt the pocketbook either. And let's see. Before I go to the last one, no, we'll do the last one first, and then we'll do the last question. The last thing that is, in terms of a specific, is recognizing the lack of white oak species in Louisiana, and trying to understand what that driver is something that's probably pretty important. So for bears in particular, having both of the families of trees, having white oak species and having red oak species, creates a more stable source of food. They often produce in off years. They often complement each other in terms of production, and so you can count on white one year and maybe reds do better in another year, et cetera, et cetera. So if it's feasible to not only find individual species who are good producers of white oak to sow into plantings of some of these forests to get a small component of white oak, that would be something that would potentially be really good for black bears. Okay, I'm going to stop there for just a second, and can we do the third poll question now that they've got the general recommendations, Toby?
And here it is, and this one deals with challenges to forest management for bear. closing in on 1 minute. I'll give you guys about 10 seconds more to vote. And with 83% responding, we have a pretty much evenly between loss of revenue, difficulty in implementation, and all of the above. So,
okay.
not particularly informative. All of these, except for labor costs, are significant, or these two in general, or three.
Okay. That's interesting. All right, while we're doing that poll, let's go ahead and just do the last one, Toby, because that will be helpful as I conclude.
Based on what you saw and heard today, in what format would you prefer to get results from this project? A question about how to best disseminate the information. So in about 10 more seconds, looks like the voting has just about leveled off here.
Okay.
And again, with about 83% voting, it looks like there's a preference for web-enabled platforms and extension documents.
Okay. Okay,
Also,
perfect.
surprisingly, large number of people in favor of peer-reviewed journals.
Who is not in favor of peer-reviewed journals? Okay, that's a perfect segue. So as we wrap up, let me go ahead and tell you a couple things that are happening right now. So as I've said, the D squared is actually available, will be available. It has to be made public, but it's going to be on the database, and so you can download it and actually use it in GIS for however you see fit. The report is going to be sent to you in a link. We do have two articles that are being prepped for peer-reviewed journal articles, one that is concentrated more on the habitat modeling and one that is concentrated towards forest ecology in terms of what we've found with some dynamics. So you can look for that as well. Certainly extension documents would be extremely useful, and I see how that could easily be done. The work, as tends to happen with my projects, kind of turns into this, web of things kind of shooting off in different directions. And one thing that Joe Clark and I had several long conversations about was being able to tie that habitat model to demographics, because we're seeing a push away from collecting really intensive demographic data. So if we're able to correlate a habitat model value to better demographics, it saves us a lot of field work, invasive work, and helps us on a much larger landscape scale. So we're in the process right now of building this entire model for the state of Florida. And we're doing that because the state of Florida, unlike Louisiana has done bear hair snares where there's good bear habitat. Florida has done it across the range of from pretty poor bear habitat to very good bear habitat. And so what we hope to do is correlate the number of individual bears and potentially a few other characteristics at each hair snare from bad habitat to good habitat and see what relationship those variables have to my D-square score. If we're successful, then we'll be able to actually link this habitat model to demographics. So not only is it telling you something about the habitat, but it's going to tell you something about the quality of the bear population itself, which is pretty exciting. The second thing is that we're advancing the LiDAR analysis using LOS tools, which is a program that does a very good job at getting some of this to try and start to quantify biomass. And we're also using the spatial extension in ArcGIS and FragStats to get at a better able to kind of describe how to best do these types of cuts, like where do they actually, if you were looking at that 50% versus 25 versus 25, like what does it actually look like and what would that mean in terms of a forest management plan? So those are kind of our long goals for the project and how we're moving forward right now. And with
Thanks,
that,
Jennifer.
I am done, and yeah.
I'm sorry.
That's okay.
I wasn't sure where you were going, but I just wanted to let you know that we did get a couple of questions.
Okay. All right,
And
perfect. Hold on,
so the first one is from, I'm probably not going to pronounce this name correctly, Tan Wen, I think. And I'm going to try and unmute him. Are you there?
Yes, I'm here.
You can go ahead and ask your question.
So my question is, I'm interested in knowing how did you validate your D2 model, and if you did the sensitivity analysis and uncertainty analysis for your model. Thank you.
Yes. So I probably glossed over it too quickly. So we validated the model with about 3 or 4 versions of bootstrapping. So we did that first. We did leave one out with the home ranges, and we did random subsampling of the home ranges, and reran the model and recreated the threshold and saw how many home ranges actually, how the model was affected and if it ended up failing. But then we validated it with independent data. So we have GPS collars on bears that weren't included in this model. So we looked at their location and their home range scale and saw so we built home ranges for these bears who weren't in the model, and then we looked at the average D-square value for their home range. We looked at the average D-square across, I don't know, 25,000 locations. And the model did really, really well. So we did a tremendous amount of independent testing of the model. And it's in the report. I just didn't want to bog people down with the data. Does that help?
Okay, yeah, thank you. So how about a sensitivity analysis and uncertainty analysis?
Yes, so we manipulated some of the actual variables in the model to see what was a primary driver in terms of, but and maybe you want to give me more detail, but the other thing is that when you, at least for D-square, when you pull out a home range and you see the new value of D-squares, that serves as a sensitivity analysis because you start to see the impact that each individual home range has on it. So we did sensitivity from both ends. We did it from the bear end and from the variable end. So I hope that helps.
Okay, thank you. Thank you so much.
Sure.
Okay, Jennifer, we also have a question from Kenny Rebeck, and I'm going to unmute you. Kenny, would you like to ask a question? Are you there, Kenny?
Can you hear me?
Yes, we can hear you now.
I was just making more or less a statement that the use of the FIA data really seems to be misleading in what's presented relative to the forest structure that we're aware of in Tensas and Chapalaya. And really, FIA data is taken at such a grand scale that it's really not meant to be used for the local regional application like it's been used in what you presented. And I question that because of how the data that you presented and your reference especially to low abundance of red oak in the Tensas and then the no apparent presence of white oak in Chapalaya. And where those plots take place has a great deal as far as what it's representing, because our knowledge up there is the Tensas red oak composition is much heavier than what your data seems to indicate, which can be very easily explained by utilization of FIA data. And the same with the Chapalaya. There is a fair amount of white oak, mostly in the overcup composition, but it can be very easily missed because of the way FIA data plots lie in the basin. So I was just putting it out there for you. I think the model seems to have a lot of good implication, but I would be very wary of putting so much faith in utilizing the FIA data for such small regional extrapolation.
Right. Okay. Well, first of all, thank you very much. That's very insightful. I don't. most of the emphasis was on white oak, not red oak. I certainly recognize FIA plots are not stratified in any way throughout, and I know maybe less so Tensol, but certainly Atchafalaya, it's extremely variable, and we saw that in the LiDAR. I mean, it's almost like 2 or 3 different kinds of forests in there, and you should be looking at them individually. So, you know, maybe a disclaimer can be put on the report saying that this is, you know, based off of the FIA data, and so it's going to be specific of where they are. We had pretty good general ideas of where these individual plots were, and we had access to all the data that's been collected there for a while. And the location of the plots wasn't necessarily misrepresenting where bears were, but we certainly, I mean, your point is very well made that we haven't represented any kind of cross-sample of everything that's going on in Tensol and Atchafalaya. And there's really no way to get away from that except to recognize it and have people like you who actually know the area say, you know, this isn't really reality for a lot of these places. So certainly we need that kind of information, and if you know, you look at the report and you're like, yeah, this isn't, if you start to look across all of the Atchafalaya, you're going to see that this is different. Or if we sat down with, you know, Weyerhaeuser or whoever, and they were like, yeah, actually we have a huge component of white oak. Red oak was never missing, really. But then we can make adjustments to that. But this was what we had to go with, and I'm happy to include a disclaimer about it being FIA data.
Thank you.
Sure, thank you.
Okay, and we have time for one more question, I think. This question is from David Telesco, and I'm going to unmute him. David, are you there? You might have to unmute your phone. Well, actually, he's not on a phone, actually. I'll just read his question. He says, are there plans to see how this model applies in other parts of the coastal plain?
Well, I know David very well. Dave, if you can hear me, I hope you're doing well. In terms of coastal plain, I mean, we wanted to, if we have time, and the project is kind of stopped, but if we have time and manpower, we'd like to extend it through GCPO. We did it all the way to the coast, even though that's not technically in the area, and that's because that's where we had the data. We are going to do it for your state, all of Florida, which you'll be able to have access to. Beyond that, you know, into the surrounding states, there were no current plans to do it, but it's a pretty simple model, and honestly, you know, giving you the AML is pretty easy. So if we have states who wanted to do it, I'm happy to facilitate that and make it happen. So far, it seems really good. I'm really interested to see how it transfers to other areas. The biggest hurdle is that because we did crop-specific data for the bears, every time you add a new state, especially Florida, Florida is going to be a nightmare. You have to weight every single crop within bear range. And so that's probably the biggest problem. You know, honestly, once we've had Florida, maybe everything will be fine. It'll be really easy to run for the rest of the coast. But right now, there's no plans, you know, for any Mississippi, Alabama outside of, you know, the areas that we've already done.
Okay, thanks, Jennifer. We are almost to the end of our hour, and there aren't any more questions right now from the audience, and I just wanted to point out to folks, anybody who's interested in applying for continuing forestry education credits, I have uploaded as handouts that you should see available to you the certificate as well as the directions for getting credit. And if you have any questions, I'll also include information about this in the follow-up email, and everybody will get access to a link to the report, and if it's ready, also a link to the data set on our database and conservation planning atlas in a follow-up email. So with that, I'll just say thank you very much, Jennifer Moreau, and thank you everyone for attending.
Yeah, thank you for having me.